Today, the Murray River flows across southeastern Australia before eventually reaching the Southern Ocean. It is Australia's longest river system, a ribbon of water that drains an area larger than France and Spain combined. The river's path feels permanent, as though it has always flowed in the same direction, and as though it has always reached the sea. But for nearly 2 million years that wasn't true. The Murray River never reached the ocean. Instead, its waters flowed into a gigantic inland lake. A lake so large it covered much of the modern Mallee. A lake that stretched across South Australia, Victoria and New South Wales, and a lake larger than many countries. Then, after surviving for almost 2 million years, it vanished. The shorelines disappeared, the water drained away, and one of the largest lakes in Australian history was almost completely forgotten. This is the story of Lake Bungunnia. In the previous episode, we explored the Murray Sea, an ancient marine environment that flooded large areas of southeastern Australia millions of years ago. That sea eventually retreated, the ocean withdrew southward, and a seafloor emerged. And over time, the Murray Basin began transforming into a landscape that looked increasingly familiar. But the story did not end when the sea disappeared. In fact, one of the most extraordinary chapters in the geological history of southeastern Australia was still to come. To understand that chapter, we need to travel back roughly 3 million years. At the time, the Murray-Darling Basin was a very different place. The climate was generally wetter than today. The great river systems of eastern Australia carried enormous volumes of water across the continent. The ancestral Murray River flowed through a landscape that was still evolving, and deep beneath the surface, tectonic forces were slowly reshaping southeastern Australia. The changes were subtle. No mountain ranges suddenly appeared. No dramatic volcanic eruptions transformed the landscape. Instead, the Earth moved gradually, almost imperceptibly. Yet the consequences would be enormous. In the southwestern Murray Basin lies a region known as the Pinnaroo Block. During the Pliocene, this part of the basin began to rise. The uplift was relatively modest. In geological terms, it may have amounted to less than a few hundred meters. But in an extremely flat landscape, even a small amount of uplift can completely alter the way rivers behave. And that is exactly what happened. The ancestral Murray River, together with rivers such as the Darling, Lachlan and Murrumbidgee, suddenly faced an obstacle. The landscape that had once allowed water to flow freely toward the ocean was slowly being blocked. For millions of years, these rivers had transported vast quantities of water across southeastern Australia. Now their path was becoming increasingly restricted. Water began backing up behind the rising barrier. The rivers continued to flow, rain continued to fall, and runoff continued to enter the basin. But the water could no longer escape as efficiently as before, and so a lake began to form. At first it may have appeared unremarkable, a broad wetland, a growing body of freshwater, but as thousands of years passed, the lake expanded, then expanded again and again. The Murray-Darling system continued delivering water from across eastern Australia. The lake grew larger, the shoreline migrated outward, entire landscapes disappeared beneath the rising water. Eventually, a truly extraordinary freshwater system occupied the Murray Basin. Geologists call it Lake Bungunnia. At its maximum extent, Lake Bungunnia covered approximately 68,000 square kilometres. This was not a small inland lake, it was a freshwater inland sea. The waters stretched across southeastern South Australia. They extended into northwestern Victoria. They flooded parts of southwestern New South Wales. Where today there are Mallee scrublands, salt lakes and semi-arid plains, there was once open water extending toward the horizon. The Mallee region as we know it did not exist. Instead, vast areas lay beneath the surface of one of Australia's largest lakes. The evidence for this remarkable environment remains preserved within the sediments of the Murray Basin. As the lake expanded and contracted through time, it deposited thick accumulations of clay and silt. These sediments eventually became known as the Blanchetown Clay Formation. Within those deposits is a detailed record of changing water levels, shifting climates, and a long history of the lake itself. Remarkably, geologists have been able to reconstruct much of that history using magnetic reversals preserved within the sediments. Throughout Earth's history, the magnetic poles have repeatedly switched positions. When sediments accumulate, magnetic minerals can preserve a record of the magnetic field that existed at the time of deposition. By studying these reversals, scientists have been able to establish a timeline for the evolution of Lake Bungunnia, and that timeline reveals a fascinating story. Lake Bungunnia was not a static body of water. Its size fluctuated dramatically. There were periods when water levels dropped, periods when shorelines retreated, and periods when the climate became drier. Between approximately 3.2 and 3 million years ago, several low water events occurred. Then conditions became wetter, the lake deepened, water levels rose and the system expanded. Later, around 2.8 to 2.6 million years ago, conditions became drier once again. The lake contracted, sand deposits accumulated around its margins. Then conditions improved and water levels recovered. But perhaps the most astonishing event occurred around 2.5 to 2.4 million years ago. During this period, the lake appears to have dried almost completely. The giant freshwater system that had occupied much of southeastern Australia virtually disappeared. This coincided with major climatic changes occurring around the globe. The northern hemisphere ice sheets were beginning to expand. Climate patterns were shifting. Conditions became drier across many parts of the world. For a moment, it appeared that Lake Bungunnia's story was over. But it wasn't. The lake returned. Over the following hundreds of thousands of years, water levels rose again. The basin refilled. And once more, Lake Bungunnia spread across the landscape. From approximately 2.4 million years ago onward, the lake entered another long phase of expansion and persistence. For hundreds of thousands of years, it remained one of the dominant geographical features of southeastern Australia. Its existence also tells us something important about Australia's climate. Modern southeastern Australia is comparatively dry. Large parts of the Murray Basin experience high evaporation and limited rainfall. Maintaining a lake the size of Bungunnia under modern conditions would be extraordinarily difficult. The fact that the lake existed at all suggests a very different hydrological regime. The rivers feeding the basin likely carried significantly more water than they do today. Rainfall across large parts of the catchment was probably higher. The landscape itself may have looked greener and wetter than the environments familiar to modern Australians. Lake Bungunnia therefore represents more than just a lake. It represents a lost Australia. An Australia that existed before the full development of the arid continent we know today. Yet despite its immense size and longevity, Lake Bungunnia would eventually meet the same fate as the Murray Sea before it. It would disappear. The exact process took time. The southern barrier that had helped impound the lake did not remain intact forever. Eventually a breach developed. Water found a pathway through the elevated terrain. Once that pathway formed, drainage became increasingly effective. The lake began losing water. Shorelines retreated and former lake beds emerged. The giant freshwater system fragmented. Large bodies of water became smaller basins, and smaller basins became isolated lakes. The era of Lake Bungunnia was coming to an end. By roughly 700,000 years ago, the lake was largely gone. The waters had drained. The giant inland lake that had dominated southeastern Australia for nearly 2 million years had vanished. Yet its disappearance transformed the continent. As the lake drained, water carved new pathways through the landscape. The modern Lower Murray River began taking shape. The river system we recognise today was born from the collapse of the giant lake that preceded it. Even now, traces of Lake Bungunnia remain visible across southeastern Australia. Lakes such as Terrell preserve fragments of the former system. The Menindee Lakes occupy parts of the broader landscape influenced by its history. Ancient lake sediments continue to underlie large areas of the Murray Basin, and the Mallee itself owes part of its modern appearance to the environmental changes that followed the lake's disappearance. Perhaps the most remarkable aspect of Lake Bungunnia is that it demonstrates how dramatically Australia can change. The landscapes we often think of timeless are anything but. A few million years ago, southeastern Australia contained one of the largest freshwater lakes on the continent. A lake created by subtle tectonic uplift, sustained by a wetter climate, and one that survived for nearly 2 million years. Then, through a combination of geological and climatic change, it vanished. In its place emerged the modern Murray River, the Mallee, the Salt Lakes, and the increasingly arid landscapes that define much of inland southeastern Australia today. The story of Lake Bungunnia demonstrates that even the largest geographical features can be temporary. Oceans come and go, rivers change course, lakes appear and disappear, and the Australia we know today is simply the latest chapter in a much longer geological story. I hope you found this as interesting as I did, and as always, thanks for watching.
Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.